Okay. So in third module, we will learn energy principle. In that, we will learn for a statical indeterminate structure, calculate slope and deflection by using a Castiglione of first theorem. And basically, Castiglione of second theorem is used for indeterminate structures to analyze the structure. So analyze, that means to calculate support reaction and draw shear force diagram and bending moment diagram. And last topic is also a very interesting topic, that is the approximate method. Forces in a frame structure subjected to vertical and lateral load. આટલો normal topic લખીને છોડી દીધું છે, બરાબર. એમાં topic cover કરવા તો બહુ બધા topic cover થઈ શકે છે. Okay, we can cover lots many topics, but basically two methods are important. One is a portal method and another is a cantilever method. Okay, I think આનું પણ recording available છે. I will share later on, don't worry. Next, last topic is again one of the important topic, structure subjected to moving load. So suppose we are considering the bridge kind structure. in a bridge kind structure, can I say that if any vehicle move from one location to another location, in that case, can we predict normalized condition for shear force and bending moment, like if you are simply supported beam subjected to central point load? In that case, your bending moment diagram will be WL/4. એવું કે એમાં પ્રેડિક્ટ કરી શકાશે? કરી શકાય જ્યારે મૂવિંગ લોડ હોય ત્યારે? પ્લીઝ ટેલ મી.
યસ સર.
ના કરી શકાય ને? ક્યાંથી કરી શકાય? સપોઝ એક પોઈન્ટ પરથી બીજા પોઈન્ટ ઉપર કોઈ લોડ મૂવ થઈ રહ્યો છે. ઓકે, if any vehicle load is moving
केस में नहीं पॉसिबल है सर.
it is not
रनिंग
possible.
केस में पॉसिबल नहीं है.
नहीं possible है. Okay, so that for that particular case, specific method is available, that is the influence line diagram, and it is most widely used method for designing of the bridge structure. Right? Again, in this particular topic, we have to learn determinate structure as well as indeterminate structure. તો આપણો આટલો syllabus છે. Is there any question regarding syllabus? Syllabus regarding કોઈ question છે? Is there any question regarding syllabus?
No sir.
Chalo, fine. So now we are going to start module number 1. Module number 1, that is slope and deflection method. Okay. What you can say of slope deflection?
અંકિત ને લાગ ઘડીક આવે ફોન આમાં આવે છે એટલે એમને પેલું શું એમને મારામાંથી માગી જો ના ના આમાં મારો તમ તારે ના માર લેક્ચર ની.
Fine. So module number 1 is the slope deflection method. Now before starting slope deflection method, let me first of all cover basic of structural analysis 1, which is required for this particular topic only. Right? So what is the statically determinate structure first of all? Can anyone tell me? Can anyone tell me what is statically determinate structure?
Sir, M is equal to 2J plus R.
I don't want any equations. Okay, I want fundamental answer.
Fundamental. Member is equal to
internal external forces.
Both are equal.
Yes, good. Fine, chali. Let me try to understand what is a statically determinate structure and what is a statically indeterminate structure. So a structure which is capable to analyze by using static equilibrium condition alone. Okay, if we are able to analyze a structure by using static equilibrium condition, static equilibrium equation alone, such a structure is known as a statically determinate structure. Now first question is that what is the static equilibrium conditions? Can anyone tell me? Please unmute yourself. Please mute yourself. Can anyone tell me what is the static equilibrium condition? Can anyone tell me?
Number of unknowns and number of conditions same hoy.
No. What is static equilibrium equations? Suppose I am considering the 2D structure like a beam. Okay.
Okay.
Suppose I am considering the 2D structure like beam, and I am applying the random kind of loading on a beam. So what is the behavior of beam? Okay, whatever direction I will apply the load. So let's say, can we say that due to application of this load, it may be possible your beam will be deformed? Yes or no? Due to application of load, your junction of the beam or junction of the structure may be moved from one location to another location. Yes or no? And due to application of load, your beam will be rotated or junction will be rotated depending on kind of fixity available. Agree with me? Yes or no? इतना clear है? Please interact. Huh? Is it clear or not? Please confirm. So to equilibrium your structure, what we need first is sigma fx equal to 0. That means algebraic summation of all force in x direction, that should be equal to 0. Second, sigma fy should be 0. Algebraic summation of all force in y direction should be 0. And next, sigma mz. Now ymz I will discuss, don't worry. That should be equal to 0. So now let me try to understand a concept of moment. I think all of you are knowing the what is the moment by example of door. Okay, door na example thena samajhano try kariye. What?
Hello.
Yes.
Sir, sigma fx 0, sigma fy 0, तो sigma am શું બોલે સર પાછળ?
mz.
mz.
Okay. Now why mz I will explain. Don't worry. Let me take an example of door. Door basically connected with frame by means of mijagra. Yes or no? Agree, sure? Please confirm me. Clear?
Yes,
So now let me try to understand function of the support. Let me try to understand function of support. Suppose I am applying the load on this particular structure like this. I think I have already discussed in SA1 lecture also. Please mute yourself. If it is required, then only unmute yourself, because it is disturbing the lecture. Suppose this is fx or force applied in x direction. So due to support characteristics, can I say that there is no movement in x direction? Yes or no? Door no example last lecture ma joyelu. Similarly, if I am applying the load in y direction, again due to support characteristics, it will be not moving in a direction. But if I will pull or push door out of the plane, say this is your x direction, this is your y direction, this is your planar area. So your out of plane, that means z direction. Yes or no? Agree, Shobada? Out of plane, that means z direction. Yes. So now just observe, if I am applying the load in z direction, what will happen? What will happen? Tell me, Charlie. If I am applying the load out of plane, that means in z direction, what will happen? Tell me. I want answer from your side, students, please.
Sir, move thase na, door open or close?
No, it will be rotate. Yes or no? Door will be rotate. I want specific word. Your door will rotate. Yes or no? Either inside or outside or clockwise or anti-clockwise direction.
Yes, sir.
Okay, so that
Yes, sir, noted.
That rotation is nothing but moment. Now, so can I say that that rotation actually occurred for mz direction due to application that is actually occurred in mz direction? Agree with me? why I am writing here MZ, that now it is not required to mention MZ, but I am trying to explain fundamental concept. Okay, so for an example, if I am considering the beam, so basically we can consider x and y direction. So that's the reason I am mentioning here MZ equal to 0. Is it clear? Please confirm me. Itna clear hai?
Yes.
Fine. Chaliye. Now, so to make your structure in an equilibrium condition, we must have 3 conditions. Now, why these 3 conditions? Now, this is the example of beam. Whatever kind of the load is acting on beam, whatever kind of load is acting on beam, like this. So can I say that all forces are acting in a same plane? Yes or no? एक ज plane માં લાગશે. And but all force does not meet at single point. એક point આગળ તો મળવાના નથી. Agree છો? So such kind of load is basically known as a coplanar non-concurrent forces. Yes or no? Such kind of load is known as the coplanar non-concurrent forces. Is it clear or not? Please confirm. Atlu clear છે? Is it clear or not?
Yes, sir.
Okay, so such kind of forces are known as a score. Now, why I have considered 3 equilibrium condition? So let me first of all understand concept of the coplanar non-concurrent force system. Let us consider body. In this particular body, say I am applying one load at this point, another load at this point, another load at this point. So can I say that this all 3 force doesn't meet at single point? Yes or no? अलग अलग point આગળ લાગે છે એવું કહી શકાય. Say this is your center of gravity point. Yes or no? These all forces are acting at a different point. So due to application of such kind of forces, what will happen in your particular structure? Sorry, your structure will translate. That means linear deformation, either in x direction, either in y direction, depending on intensity of loading, or your structure will try to rotate also. Yes or no? Agree cho bada? Because all forces are acting at a different point. Is it clear or no? Just observe and visualize the system. Itna clear hai? Students, please interact. Huh? Is it clear or not? Fine. Na? So such kind of structure is basically, such kind of system is basically known as a coplanar non-concurrent force system. And to make a equilibrium such a condition, what we will require? We must require algebraic summation of all force in x direction, because there is a translation in x direction. Algebraic summation of the all force in y direction must be equal to 0, because there is a translation in y direction. And algebraic summation of moment about a point must be 0. Now that moment will be in z direction. I have already mentioned. So moment of the all force in z direction that must be equal to 0. So I hope it is clear to all of you why I have mentioned here 3 equilibrium condition. Now please consider we are dealing with a 2D, not 3D. Is it clear or not? I hope it is clear to all of you. Itna clear hai?
Yes, sir.
Fine. So now for a statically determinate structure, if your structure are able to analyze using these 3 conditions alone, such a kind of a structure is known as a statically determinate structure. So for an example, now every student will type in chat box or give me answer in chat box which kind of beam I have drawn here. कोई बोलसे नहीं, बताए chat box में आंसर आपको. There are 11 students in group in a lecture. Type in chat box which kind of beam I have drawn here. તમને ખ્યાલ જ છે. And also mention name of supported point A and name of supported point B. चलिए. It is not a part of SA1. It is part of your basic diploma level. Yes, good. नो मयूर भाई, फिक्स सपोर्ट तो नहीं है. Fine, but still you are right. Yes. Okay. So this is a simply supported beam. Okay, this beam is a simply supported beam, and point A is your hinge support, and your point B is a roller support. I hope it is clear to all of you. Okay, now I am not going to discuss what is a hinge support, what is a roller support. Okay, I am assuming that all people are knowing concept of hinge support and roller support. Now tell me number of reaction at a hinge support. चलिए मेरे को ये बताइए first of all, how many number of reactions at hinge support? Hinge support पर कितना reaction આવશે અને roller support પર કેટલા reaction આવશે? Tell me first.
hinge support में
2 आएगा.
Please give me answer in chat box only, so all people can give me answer. Okay, so I am capable to understand what you people are knowing or not. Okay, please give me answer in chat box. Okay, for a hinge support, chat box માં આવી રીતે લખો hinge dash reaction, roller dash reaction. ચાલશે આ રીતે લખશો તો. Okay, so for a hinge support basically 2 reaction, and roller support basically 1 reaction. Okay, so this is symbolic representation of hinge support. 1 reaction vertical, another reaction horizontal. Okay, now if we are considering the 2D structure, for any any free junction, it will capable to move in a 3 particular direction. Say that is say I am considering the cantilever beam like structure. This is your free junction, so it will be free to translate in x direction, it is free to translate in y direction, and this junction capable to rotate. Is it okay? Capable to rotate, is it okay? I am discussing the free junction, not a fixed junction. Is it okay? So any free junction is capable to translate in 2 direction, one in x, another is y, and rotate in 1 direction. Yes or no? Any free junction. Agree, Joe? And this is nothing but your degree of freedom. Is it okay? इतना clear है? Fine. Now, similarly, now why I am discussing this, it will be discussed later on, don't worry. Similarly, suppose I am considering the roller support. Such a support consists only 1 reaction, vertical. Fine. Now, this is not an exact definition. Suppose I am providing the roller support like this. In this case, your roller support will carry a horizontal reaction. Agree with me? Please confirm me. આવી રીતનો roller provide કરું તો આવું કંઈક junction છે, આ રીતે member provide કર્યો છે. So in case of the roller support, basically reaction is perpendicular to surface of the support. Now, this case, consider this case. In this particular case, your surface of the support is in x direction. Yes or no? So your basically your reaction will be a perpendicular to surface. And in this case, your support surface in y direction. Yes or no? So that's the result. As per fundamental concept of roller support, your reaction will be in x direction. Is it clear or not? Please confirm me. इतना clear है? I hope it is clear to all of you. Surely, fine. Next, suppose I am considering the fixed support. Now tell me in chat box number of reaction at a fixed support. चलो fixed support पर कितना reaction आवશે? Tell me. Yes, good. Fixed support पर 3 reaction आवશે. Good. Vertical, horizontal and rotation. इतना clear है सबको? चलिए fine. Now why we are going to discuss this? Let me first of all understand. Now we are going to discuss degree of freedom for junctions. Now, just consider for a hinge support, number of reactions are 2, yes or no? For a hinge support, number of reactions are 2, yes or no? For hinge support, number of reactions are 2. So as per now, what is the purpose of, what is the function of reaction, or what is the function of support? To carry the load which is which is required to resist, yes or no? To carry the load which is required to resist, that means it will restrain a junction depending on requirement. For an example of the door, what is the purpose of door? It is the opening and closing of door. That means it will not require. Now I am considering a normal door, okay? Sliding door ni baat nathi karta hu. I am considering only normal door. In a case of the normal door, the purpose of door is the opening and closing. That means opening and closing in terms of the rotation, yes or no? Opening and closing basically traditionally in form of the rotational movement form, yes or no? Agree, sure? So it will not require any movement in either x direction or y direction, yes or no? Such a support or such a junction does not require any movement in x direction or y direction. That's the reason there is a 2 reaction for a hinge support. And if I am considering the hinge support, your junction will capable to rotate. Agree, Joe? Please confirm me in chat box. All of you are agree with me? Your hinge support is capable to rotate. That means there is some slope, basically denoted by theta. Okay, basically denoted by theta. That is known as a theta. So there is some slope available for a hinge support. Okay, due to it is a free to rotate thigh support. Similarly, if I am considering the roller support, you have only one reaction, vertical reaction. So as per concept of the support, your support is free to translate in x direction, yes or no? For such kind of case, for our case ni baat kari raho chu, it is free to translate in x direction and it is free to rotate, yes or no? So there is a 2 translation. One is translation in x direction, another is a rotation. Here only rotation. And if I am considering the fixed support, now can anyone tell me number of how many number of translations available? Fixed support can move, yes or no? No. Barabar. So your fixed support will not able to move in any direction. Just take an example of door. Instead of the Mijagra, just weld your door. If I am weld the door, your door will not able to rotate also. Rotate pan nahi thi sakta. That means it will become a rigid. It will not rotate in any direction. I hope it is clear to all of you. This is a deformed shape of the beam. So for this particular junction, theta is also 0, x is also 0, y is also 0. In this case, x not 0, theta is not 0. Here theta is not 0. I hope it is clear to all of you. Now, for a free junction, your free junction is free to translate in x direction, free to translate in y direction, and free to rotate. So for a free junction, you have x, y, and theta. All 3 components are available. Is it clear? So now, whenever we are dealing with a beam or frame kind of the 2D structure, whenever we are dealing with a beam or frame kind of the 2D structure, in that case, basically what we will do, we will neglect axial deformation. Axial deformation to be neglected. Is it clear? Basically, we will neglect the axial deformation. Now, just simple visualize whatever kind of the structure are there. What is the which kind of the load basically comes on a beam in a majority condition? Basically, vertical loads are there on beam. Yes or no? Vertical load is also fine na. Horizontal load will be there, but there is a significantly very less magnitude of the loads are there. Yes or no? As compared to vertical load. So that's the reason what we will assume axial deformation to be a neglected. I hope it is clear to all of you. इतना clear है? इतना clear है? Sure. So now let us move to our basic concept. What is statically determinate structure? Statically determinate structure. Like a simple example of statically determinate structure, that is a simply supported beam. Now, let us first of all, you people forgot what why this is a why this is a statically determinate structure. Now tell me, how many number of unknowns are available in this structure? How many number of unknown reactions are available in this structure? For A, 2 vertical horizontal, and for B, 1 vertical. Yes or no? So number of unknown reaction, that is 3. And how many number of equilibrium conditions are there? 3. Yes or no? Please tell me. Is it clear? Itna clear hai? So now just simple think like a mathematics problem. If you have a 3 equation and if you have a 3 unknown, can you solve such problem? Tell me. If you have a 3 equation and if you have a 3 unknown, can you able to solve such a problem? Yes or no? Simple question है, मेरे को simple answer चाहिए. Why no? I am writing here 2x plus 3y plus 4z, that should be equal to 20. 5x plus 8y plus 6z, that should be equal to 10. And 8x plus 9y plus 10z, that should be equal to 10. Can you able to solve such a problem? Yes or no? चलो मैं simple question पण લખી આપ્યો અહીંયા. By using Cramer method or whatever the method. Okay, તમારી જોડે 3 equation છે, 3 unknown છે. Simple question, simple problem છે. Yes, we are able to solve such kind of problem. Okay, so simple. मैं શું કીધી definition તમને? What definition I have told tell to all of you? If your structure is analyzed using static equilibrium equations, that is known as a statically determinate structure. Yes or no? આવી એક definition તમને કીધેલી. If your structure can able to analyze using static equilibrium condition, that is known as a statically determinate structure. Now, how many number of static equilibrium equations are there? 3. You have 3 equations and 3 unknown. This is capable to analyze a problem. Okay, chalo બીજો example લઈએ. Suppose I am considering the cantilever beam. Can I mention here any reaction? Tell me. અહીંયા reaction mention કરું. Tell me. Can I mention reaction here? मैं જ્યાં round કર્યું છે ત્યાં. નહીં આવે બરાબર, because it is a free support નથી, no support, no reaction. So again, in this case, your number of reactions are 3 or number of unknowns are 3. Number of static equilibrium condition are 3. So can I say it is also capable to analyze using the static equilibrium equations? So this is a case of the statically determinate structure. Now I hope all of you are clear about. I hope all of you are yes, this is wrong. Okay, वो wrong था क्योंकि वहां पे कोई support नहीं था. You are right. Okay, now this is a case of the statically determinate structure. Now suppose if I am considering a structure like this, now tell me which kind of beam I have drawn here. Which kind of beam I have drawn here? Tell me. Yes. Case number A, fixed beam. Case number B, this is your fixed beam. This is your prop cantilever beam. Basically we will provide at the entrance of the bungalow kind structure. Yes or no? Simple support, column na support ઉપર expansion કા તો છજ્જા આપણે extend કરીએ છીએ. Yes or no? So simple bungalow kind structure. Now it is basically such kind of the beam normally provided for a entrance purpose. Okay, chalo. Now at a point A and a point B, we have three equations. Yes or no? We have three equations or three unknowns, three reaction for A and three reaction for B. So in this case, what are number of reactions? 6. Yes or no? And what are number of conditions? What are the number of conditions? 3 only. Now tell me, can I able to solve such a problem? Now tell me, can I able to solve such a problem? You have a 6 unknown. No, second is not a simply supported beam. Second is a prop cantilever beam. I also already mentioned here. You have a 6 number of unknown. Unknown and you have a 3 number of conditions. Okay, simple. આ ઇક્વેશન ને રિમૂવ કરી દો. ચલો, તમારી જોડે 3 unknown છે અને 2 ઇક્વેશન છે. Is it able to solve? No. Okay, so simple. If your structure not able to analyze using static equilibrium condition, such a structure is known as a statically indeterminate structure. In this case, we have 3 plus 1, 4 unknown, 3 equation, not able to analyze. Yes or no? Now, one question occurs in your mind. Say I have discussed here. We are going to neglect axial deformation. So now, why I have considered here axial force? Now let me ignore this axial force. Let me ignore this axial force. Let me ignore this axial force. Now let me calculate number of unknowns for yes or no. Number of unknowns for yes or no. Agree છે બધા? Now if I am ignoring axial force, so can I say that I must have to ignore axial condition? That means sigma fx must be ignored. Yes or no? Sigma fx must be ignored. If I am ignored axial reaction, in that case I must have to ignore sigma fx. Yes or no? So in that case, your number of conditions are 2. Again, it is a case of statically indeterminate structure. Again, in this case, this reaction will be ignored. So again, number of reactions are 3, number of conditions are 2. I hope it is clear to all of you. इतना clear है? Clear है ना? चलो. Now, next, for a starting of the module number 1. For starting of the module number 1, first of all, you people have to remember some of the formulas. That is the fix and moments. Fix and moments. Okay, you have to remember equations of the fix and moments. Now, fix and moments is basically derived from the fixed beam. Okay, and it is a part of the structural analysis 1. But in a case of the slope deflection method, we will require only value of fix and moment. So you have to only remember that value. Fine. कैसे derive करते हैं वो, that will be discussed in structural analysis 1. So your fixed beam, that is a subjected to central load. Keep my words. Your fixed beam subjected to central load. Okay. I am writing in short form. Fixed beam subjected to central point load. Is it okay? Your fixed beam is subjected to central point load. So basically, for a left support, our moment will be anti-clockwise. On right support, our moment will be a clockwise. Is it okay? इतना clear है? इतना clear है? Now, just tell me, from a kind of load, whatever kind of load is applied, can I say that value of the moment at A and B must be equal because we have applied symmetrical kind load? Yes or no? This is your MFAB. This is your MFBA. Yes or no? Because we have applied symmetrical kind load, because your load is acting on a center of the beam. So can I say that end moments must be equal and opposite to make your structure in equilibrium condition? So your value will be equal to MFAB. I think you people already know that value, minus WL by A. By minus because this sign is anti-clockwise. Yes or no? anti-clockwise movement basically taken as a negative value, clockwise movement basically taken as a positive value. You can change this sign. There is no thumb rule to take clockwise positive, anti-clockwise negative, but basically I will consider clockwise, anti-clockwise, negative, positive. Okay, respectively. Right. Now I have discussed here only moment, not a bend. In a case of the plotting bending moment diagram, that there might be a different sign convention. Okay, we'll discuss later on. Similarly, MFBA, that should be equals to plus WL. I hope it is clear to all of you. Now let me discuss second case. If your beam is subjected to uniformly distributed load throughout its span, again it is a kind of the symmetrical loading, yes or no? Again it is a kind of the symmetrical loading, yes or no? Fixed beam subjected to UDL throughout the beam. Again, left anti-clockwise, right clockwise. This is your MFAB. This is your MFBA. And your value of MFAB will be a negative one, as we have discussed. Minus WL square by 12. MFAB, that should be equals to plus WL square by 12. I hope it is clear to all of you. Itna clear hai? Is it clear? Please confirm me, students. Chaliye. Let me consider third kind of the beam. If fixed beam subjected to eccentrical kind of loading. Now, what is eccentrical? Can anyone tell me in chat box? What is the meaning of eccentrical? Can anyone tell me in chat box? What is the meaning of eccentrical? चलिए बताइए. What is the meaning of eccentrical?
एक बाजू जे लोड लागतो હોય એને એવું કહેવાય છે.
No. Now just consider first case. Your load is acting at center of beam. Yes or no? Your load is acting at center of beam. Now, what is the eccentrical kind of load? Your load supposed not to act at a center point of beam. That means location of load is a different distance A and B from left and right support. Is it clear? That means suppose sorry, your length of the beam is a 10 meter. Okay. In a case number A, that is a center point. If your length of beam is a 10 meter, in that case, location of load from point A and point B will be a 5 meter each. Yes or no? But in second case, ये वाला case, eccentrical load case, in that case, your load, again length is 10 meter, your load will be supposed to act from point A maybe a 7 meter and from point B maybe a 3 meter. Such a condition is basically known as the eccentrical load condition. Is it clear or not? Please confirm me. I hope it is clear to all of you. Fine. Chalo. So now, here clearly seen that your load is an eccentrical one. That means it is not a case of the symmetrical condition. Yes or no? Symmetrical wala case to hai hi nahi. So in that case, your MFAB and MFBA both are different. So MFAB, that should be equals to anti-clockwise, that's the reason negative W A B square divided by L square. Okay, सामने length no square आवશે. Far length square करना है. MFAB, sorry BA, that is equals to plus W B A square by L square. Okay. Now, suppose if you have any confusion regarding why, how to mention AB and BA, suppose we are at a point A. So can I say that AB if we are at point B, can I say that BA? That's the reason I am writing here MFAB and MFB. I hope it is clear to all of you. For AB, your far end will be a B. That's the reason B square. For BA, your far end is a A, and its length is a A. That's the reason A square by L square. Is it clear or not? Please confirm me. इतना clear है? This is the third condition. Chalo. Fine. Now, suppose there is a fixed beam. As we know, due to characteristics of the fixed support, your support not able to rotate or translate. But if there is an unavoidable circumference, in that case, it may be possible your support will be rotate. Yes or no? It may be possible. ये possible है. ये possible हो सकता है. Due to overloading or due to some temperature effect, it may be possible some rotational effect is there. Yes or no? Everybody with me? Please confirm me. Please confirm me. Screen is shared or not? Screen is visible to all of you or not? Please confirm me. Okay. Screen is visible to other students. Please, Arsil bhai, please check.
Yes, sir.
Arsil bhai, please check from your side.
No sir, नहीं आती.
કોને નથી આવતી?
આવે છે સર. મારામાં આવે છે સર.
Arsil bhai, there is a screen is visible to other student. Okay. So there is a problem from your side. Please check from your side. Right? Chali.
Okay.
So now there is some condition like that. In a case, it may be possible your fixed support may rotate. Yes or no? Yes or no? Can I say that? Fine. So in such a case, there is some fixed moments are developed. Okay. In such a case, there is some fixed moments are developed. Suppose I am assuming for a fixed beam, point B is rotated by theta degree. Okay, theta degree. Say that is a theta B, and in a clockwise direction. So I am here writing here fixed beam subjected to end rotation. At support B in a clockwise direction. That is value theta B. I hope it is clear to all of you. So now, how these equations are comes, we will discuss in a essay structural analysis 1 fixed beam part. Okay. Now, which kind of rotation we have assumed here? Tell me. કેવા પ્રકારનું rotation assume કર્યું છે? Clockwise or anti-clockwise?
Clockwise.
Okay, we have considered clockwise rotation. Now, this is our assumptions for writing the equation. Huh? So it may be possible in example anti-clockwise rotation also given. So in that case, we have to correlate such a same condition for anti-clockwise. If your rotation is clockwise, so end moment must be a clockwise. Is it clear? If your rotation is clockwise, your end moment must be a clockwise. Itna clear hai? Now, whatever support is rotate, that support having a moment of the 4 EI theta B divided by length L, and far end moment will be 2 EI theta B by L. Is it clear? Keep in mind, I have mentioned same rotation for both end. બંને end ઉપર મેં same rotation mention કરેલું છે. Length is L. Is it clear or not? Is it clear or not? Please confirm me. कितना clear है? I hope it is clear to all of you. Please consider here I have consider clockwise rotation. That's the reason both moments are clockwise. Now, chalo, let me discuss some more detail for this condition. We have mentioned clockwise rotation. So to make your structure in equilibrium condition, we require some anti-clockwise couple. Yes or no? We require some anti-clockwise couple moment. Yes or no? So what is the direction of anti-clockwise? It is like this. So we will require to here produce an anti-clockwise couple. So now let us discuss couple. I hope all of you are knowing what is couple. ખબર છે couple કોને કહેવાય? I think most માં ભણી ગયા હશો. What is couple? Please tell me. To produce couple, we require two equal and opposite force which is separated by a definite distance. Yes or no? To produce a couple, we require two equal and opposite forces which is separated by the definite distance. ये ऐसा कुछ डिस्कस आपने पढ़ा हुआ है पास्ट में? Please tell me, students. Fine. So to produce a couple, we require two equal and opposite forces. Okay, see here. This is the point A, this is the point B. One force is acting in upward direction, another force is acting in downward direction. Both forces having the same value W. So we can say that this is the equal and opposite force. So to stabilize this beam, we require an anti-clockwise couple in your particular structure. So for that, we will require to produce anti-clockwise couple. Rotate these two arrows at the same time, you will get anti-clockwise moments. Yes or no? Tell me. Rotate both arrows along a time. Tell me, your moment will be anti-clockwise. Fine. So now, question is that what is the value of this particular reaction? That value is nothing but we have a simple reaction. Moment equal to force into distance. Yes or no? Yes or no? So now takes moment of all force about point B. Bada force the moment B agar lo. So can I say that I am interested to calculate MA? Okay. So now I am not going to discuss what is the value, how to calculate such a moment. Okay, because it is a divert our topic. I am writing here direct its value. Okay, so its value will be a 6 EI theta B by L square. And this is a 6 EI theta B by L square. I hope it is clear to all of you. Itna clear hai? Please confirm me. Itna clear hai? I hope it is clear to L. Just a minute. There is the L only. Okay, 6 CI theta by L is also. Okay, 6 CI theta B by L. Why is just moment equals to force into distance? We are interested to calculate force. What is your moment? What is your moment? 2 EI theta B by L plus 4 EI theta B by L. What is your reaction? Suppose I am interested to calculate moment at B point. So we have VA into L. Fine. Na? So square house. Fine. Square house. Clear? Square house. L denominator ma square thai. Is it clear or not? Please confirm. That is my mistake. Itna clear hai? At this stage, you have to remember only these equations. Okay. Now, these two equations will require in a matrix method, not in a slope deflection method. But I have already mentioned in this particular chapter. Similarly, due to some uncertainty, can I say that your fixed support supposed to deflect? Yes or no? Your fixed support supposed to deflect by delta. ऐसा कुछ कंडीशन भी हो सकता है. Agree with me? Yes or no? For that, we have a downward direction deflection. Due to this, we have downward reaction. To balance it, we have upward reaction. Rotate these two arrow at a time. We have a clockwise couple. Yes or no? We have a clockwise couple. To prevent this clockwise couple, we require here anti-clockwise movement. Is it clear or not? Please confirm me. Kitna clear hai? Okay, so now this is your delta. So what is your moment? Both moment will be have a same sign, anti-clockwise. So I am mentioning here MFAB, MFBA. So can we write here fixed beam subjected to and support settle or deflect by delta mm or delta. So for that friction moment MFAB, that should be equals to MFBA, both having the anti-clockwise. That's the reason minus 6 EI delta by L square. This is your value. Clear? और ये रिएक्शन का वैल्यू 12 EI delta by L क्यूब आएगा, 12 EI delta by L क्यूब आएगा. Is it clear or not? Please confirm. कितना क्लियर है? I hope it is clear to all of you. चलिए, let me start some basic equation of the slope deflection method. Okay, so lots many time theory is asked in exam, discuss slope deflection equation. So which I am mentioning here specific kind of the equation. Just a minute. I will tell you what is a specific question in next lecture. Okay, so let me derive general equation for slope deflection. Fine. Chal, let me derive in general equation for slope deflection. Now, for that, what we will do first of all? Okay, let me consider continuous beam. Okay, we are going to consider continuous beam. Or any continuous beam, such kind of the beam. Clear? Say A, B, C, D. From this continuous beam, let me consider any intermediate span or any specific span. Say AB. Okay, you can consider whatever the span. I am considering only AB span. Is it clear? Is it clear? This is a simple procedure for derive the slope deflection equation. I am considering the AB span. इतना clear है? Whatever support here mentioned, that is the arbitrary supports. Is it clear or not? Please confirm. And let me mention a arbitrary kind of the loading, W1, W2, whatever kind of loading is given, doesn't matter for derivation. Okay, so this is a load W1, this is a load W2. Okay, this is a AB span subjected to arbitrary kind of loading. Now, as from this geometry, can I say that rotation is just like this? Suppose there is some intermediate junction is there. Suppose there is an intermediate junction is there. So can I say that your beam will deform like this? Yes or no? અહીંયા suppose કોઈ junction આપ્યું હશે તો. Okay, or what we can say, your beam is deformed like this. Yes or no? ऐसा कुछ डिफॉर्म शेप होगा, थोड़ा विजुलाइज करना पड़ेगा. इतना क्लियर है? So let us say this this rotation will be a theta A, and this rotation will be a theta B. This is your theta A, this is your theta B, and both rotation are clockwise direction. Okay, theta A and theta B, that both are clockwise direction. Okay, so let me write here. Let AB intermediate span of continuous beam. AB is okay. Now to derive the in general equation, we have to follow some of the steps. So what we will do first of all we will consider this span as a fix. Is it clear? First case માં શું કરીશું? We consider both support as a fixed one. Okay, this is a point A, this is a point B. Whatever kind of loading, that doesn't matter. इतना clear है? So for a fixed beam, we have a left moment is anti-clockwise, right moment is a clockwise. So we have one moment MFAB here, another moment MFBA here. Is it clear or not? Please confirm me, students. Now, second case, what we will do? Second case, what we will do? I am writing here for case number 1 or step number 1 or stage number 1. Okay. A. What we will do in A? Consider both support as a fixed one. Second, stage B. In stage B, what we will do? Release moment at A. Okay, rotation of the support A will be released. But B kept as fixed. B na apne fix જ રાખીશું. Is it clear? Is it clear? What is the meaning of release? We will not consider a moment at A. If we are not going to consider a moment at A, your rotational component will be released. In that case, we have only two reactions, vertical and horizontal. So we have a hinge support at A. But at the same time, we will consider fixity at point B. Is it clear or not? Please confirm me, students. This is stage B. इतना clear है? Now, what will happen here? Suppose your point A is released by moment. In that case, your deformed shape just like this. So from this deformed shape, we have clearly seen that we have some rotation at point A like a theta A, yes or no? We have some rotation at point A, theta A, yes or no? Say again, we have consider clockwise rotation here. Okay, we have consider clockwise rotation. So again, just observe previous slide. If any support is rotated by theta degree, moment at that particular support, that is a 4ei theta by L, and on far support, that is the half of that 2ei theta by L. Same will be applied here. We have a clockwise moment at point A, having a value of 4ei by theta A by L, and at point B, same clockwise moment 2ei theta A by L. Length is L for all case. I hope it is clear to all of you. 4ei theta A divided by L, 2ei theta A divided by L. I hope it is clear to all of you. Please confirm me, students. इतना clear है? Is it clear? Now, in stage number C, what we will do? your point A will kept fixed and point B will release by moment. Okay, point B का rotation हम release कर रहे हैं. We will release the rotation of point B. So again, it will be a hinge support or roller support, whatever support you can you will consider. Okay, so your deform shape just like this. Again, we will consider here a rotation theta B. Nature is a clockwise one, theta B. So as we have discussed, you have here some moment here and moment here. Whatever support is rotated by theta degree, having a for EI theta B by L, opposite will be a half of that value. I hope it is clear to all of you. इतना clear है? Kept in mind, both rotation will be a same for both moments. Okay. Same રીતે તમે અહીંયા same way you have to write. See, rotation of support B released but A kept as fixed. Is it clear? Is it clear?
हेलो
Yes.
सर इक्वेशन बी और सी फिर से एक बार समझाओ ना.
Equation B or C. Okay. To understand
इसमें क्या
equation, to understand equation B and C, first of all understand this concept. ये वाला concept पहले समझ लीजिए. Just observe here. Your joint B is rotated by theta B. Yes or no? And what is the nature of rotation theta B? Clockwise. इतना clear है?
यस सर.
Okay. So at a point B, our value will be a 4EI theta B by L. And at point A, your value will be a 2EI theta B by L. So now whatever a junction will rotate, that junction having a value equals to 4EI theta by L. And on a far end, we have half moment. Is it clear? Is it clear?
यस सर.
Now, same we have applied in our case. In a case B, what we have do? Rotation at of support A release. That means we have released the rotation. Okay, we have a two term, restrain and release. Restrain, that means it will not move in any direction. Release, that means it is free to move. Okay, that means release means release of rotation, that means it is free to rotate. Which kind of support is free to rotate? We have already discussed. देखिए, hinge support or roller support, yes or no? Free to rotate, hinge support or roller support, yes or no? पता चला क्या बोल रहा हूँ?
यस सर.
Fine. So now we have release support. We have what we have do here. We have release support A. That means there is some rotation at point B. Sorry, rotational effect at point A. What is that effect? 4EI theta by L. And half value will be a far end. I hope it is clear to all. Clear? Same thing we have do in a C case. In that case, we have release rotation of point B. For that 4EI theta by L and 2EI theta by L. Clear? Please confirm me. Clear है?
यस सर.
है ना? चलिए.
सर एक चीज पूछना है.
बोलिए.
अपना जो सेकंड सपोर्ट है वहां पे रोलर हो हिंज हो कोई भी हो, जहाँ पे हम रोटेट करेंगे तो उसमें इक्वेशन 4EI theta B by L ही होगा.
Whatever support you will consider, just understand previous case. What we have mentioned, what we have visualized in this case, your support B is free to rotate by some angle theta. Right? That means fixity will be a somewhat about a loose. ऐसा बोल सकते हैं. Now, your support is free to rotate. So for that case, you can assume roller support here, or you can assume hinge support. Doesn't matter. Right? We have assumed here your support is rotated by theta. इतना मैं यहाँ पे assume किया है. Clear है? I hope it is clear. Can we move ahead? Please confirm me. Is it clear now? Please confirm me first. चलिए stage number D. What is our stage number D? In stage number D, we will assume that your support B is supposed to deflect by delta or settle by delta. Is it clear? Your support B is supposed to settle by delta. Delta जितना settle हो रहा है. Now, if your support B is settled by delta in downward direction, so we have provided here upward direction force. So we have a clockwise couple due to reaction. For that, we have to provide anti-clockwise moments for ends. Yes or no? इतना clear है? Or for such kind of condition, we have equation 6 EI delta by L square. Please confirm me, students. Is it clear or not? इतना clear है? Please confirm me. Is it clear or not? Fine, chali. So we can say this is the stage number D. In that case, what we can write here? Maintain fixity of A and B. Provide downward deflection at end of B. Okay, what we can write here? Maintain fixity of A and B, provide downward deflection at end B. With respect to A. Okay, so now our main intent to write in general equation of the end moment. Okay, so we have some kind of the moments here. One moment is here MA, another is M. We have various moment MAB. Now I am not considering here any sign conversion. I am mentioning here random values. Okay, random signs MBA, MBC, MCB, MCD, and MDC. Yes or no? So we are interested to calculate in general equation of the moment at particular junction. So let we consider or let we summing up all the moment at point A. Okay, so final moment at A. Final moment at A, that is MAB, because we have considered AB span, that should be equal to, chalo, start from stage A. One moment MFAB, yes or no? One moment is MFAB, yes or no? इतना clear है? So minus anti-clockwise है, इसलिए minus लिख रहा हूँ, minus MFAB. For a stage number B, clockwise for EI A theta for EI theta A by L. That's the reason, plus for EI theta A divided by L. Case number C, clockwise to EI theta B by L. Add करो, plus 2 EI theta B by L. And here case number D, this is the A, this is the B. Anti-clockwise 6 EI delta by L square minus 6 EI delta by L square. Is it clear or not? Please confirm me, students, in chat box. इतना clear है?
सर फिर से एक बार बताइए ना, final moment of at A1.
Let us consider all the moments for point A only. Okay, so for point A, case number A, we have one moment, friction moment, anti-clockwise MFAB. Yes or no? इतना clear है? For
Yes,
case
sir.
B, clockwise 4 EI theta A by L. Case C, clockwise 2 EI theta B by L. And case number D, anti-clockwise 6 EI delta by L square. We have summing up all the moments with respect to sign.
Okay, sir.
Clockwise positive, anti-clockwise negative. Clear? So now in last three term we will common out 2ei by L. Okay, last three term 2ei by L common card. So we can say that minus MFAB, that should be plus. So we have MAB, that should be equals to minus MFAB. Let me common out 2ei by L. So can I write here 2 theta A plus theta B minus 3 delta by L? Is it clear or not? Please confirm me. 2ei by L common करो तो यहाँ 2 रही जैसे जोड़े थीटा है, 2ei by L common निकल से खाली खाली थीटा B रहसे, 2ei by L common करो ले ऊपर 3 रहसे नीचे L रही जैसे. Is it clear or not? Please confirm me. This is your equation number 8. Similarly, final moments at and B and ऊपर final moment ले रहा है, same procedure MBA, that should be equals to from case number A clockwise MFBA, case number B clockwise 2ei theta A by L, case number C clockwise 4ei theta B by L, and case number D anti-clockwise 6ei delta by L square. Let me write one by one. MFBA plus 2ei theta A divided by L plus 4ei theta B divided by L minus 6ei delta by L square. Is it clear or not? Please confirm me, students. इतना clear है? Same procedure, we will common out 2ei by L. MBA equals to MFBA plus 2ei by L is a common out. What we have? Only theta A for first term, twice theta B for second term, and minus 3 delta by L for last term. Is it clear or not? Please confirm. This is your equation number B. This is the in general equation for slope and deflection. This is the in general equation for slope and deflection. इतना clear है? Now just observe. If I am considering a joint A, if I am considering joint A and observe equation, I have write final moment for MAB. Okay, that is for a joint A. Okay, we have a beam like this or continuous beam like this. What we can say? Okay, this is the point A, this is the point B, this is the point C. So now if I am considering a point A, we have fixed moments here due to loading. Yes or no? Fixed moments are available. Okay, so if I am considering the AB only, and for a point for a joint A, we have a end moment of AB. Okay, for that minus MFAB. Consider A wala equation consider कीजिए. 2ei by L is a common out. If I am considering joint A, we have considered twice slope at A, and opposite wala slope half लेना है, यानी कि theta B लेना. Is it clear? And similarly, if we consider a joint B, in that case, we have to consider a slope at B is twice and slope at A is the half one. Is it clear or not? Please confirm. इतना clear है? इतना clear है?
सर ये वाला एक बार फिर से बताइए सर.
Now, suppose I am considering, just a minute. Suppose I am considering joint A. Okay, suppose I am considering joint A, and we are going to apply the equation for joint A. So our equation is MAB. Okay, due to joint A, moment is MAB. That should be equals to minus MFAB by L, minus MFAB fixed moment for AB plus 2ei by L as it is. Now, if I am considering MAB or a joint A, we have a connecting joint B also. So we have a probable two slope here, depending on kind of junction, yes or no. So we have one slope theta A, another slope theta B, theta C, yes or no? Yes or no?
Yes sir. Yes,
suppose we are considering joint A. In that case, we are going to consider MAB. So we have two slope theta A and theta B. And we are at a end A. That's the reason theta A will be taken as twice theta A, and theta B will be taken as a theta B only. And suppose we are at a joint B. In that case, we have MBA. Again, we have two slope, theta A, theta B. In that case, theta A to be taken as theta A and theta B to be taken as theta B. You have to remember this equation in general context. Fine. चलिए एक simple example से उसको समझते हैं. Then after we will finish our lecture. Suppose we have such kind of the continuous beam. Okay, A, B, C. So we have three junction A, B, C. So we need to write separate equation for each joint. So for a joint A, we have only one span AB. Length is L for both beam. So for a joint A, can I write like MAB? That should be equals to MFAB. I am not considering here any sign. Plus 2EI by L. I am standing at point A. That's the reason slope of A should be a twice 1. Far slope to be a half 1. Theta B minus 3 delta by L. Now suppose I am considering joint B. Okay, joint B, or what we can simplify it, span AB. Okay, now at joint B, we have two connecting span, left side AB, right side BC. So for a joint B, first of all we will write equation for MBA. That should be equals to MFBA plus 2EI by L bracket. Again we are standing at point B, far end A having a half slope, theta A plus twice theta B minus 3 delta by L. And similarly, if we are going to consider MBC, that should be equal to MFBC plus 2EI by L. Again we are at joint B, far end C having a half slope, 2 theta B plus theta C minus 3 delta by L. I hope it is clear. Clear है? अभी clear है? Similarly for joint C, what we can say, MCB, that should be equals to MFCB plus, just a minute, for a joint C, MCB, that should be equals to MFCB plus 2EI by L. Now in this case we are standing at point C. Far slope should be a half 1, theta B plus twice theta C minus 3 delta by L. I hope it is clear. Clear है? Please confirm me.
Yes sir.
Clear. So इतना रखते हैं, फाइन ना, अटू राखिए छे आज. Okay. If you want to take a snapshot of all slide, you can take a snapshot. This is a slide number 1.
सर इसका वीडियो भेज दीजिएगा सर.
ये मिल जाएगा आपको
रिकॉर्डिंग.
लेकिन अब हाँ मिल जाएगा, डोंट वरी, इसलिए तो मैंने रिकॉर्ड किया है. ठीक है. This is slide number 2. This is slide number 3. 4. 5. 6. 7. And 8. Now, what we can do? Please make one group for structural analysis 2. Fine. ऐसे 2 में एक WhatsApp ग्रुप बनावी देशो.
हेलो.
हाँ बोलो.
सर आपने જે લાસ્ટ એક્ઝામ્પલ તમે હમણાં સમજાયો માં એસા એબીસીડી આવશે યા કોઈ નંબર્સ વગેરે આવશે એક્ઝામ્પલ ની અંદર?